Hi, it's Jan Beta, and today I'm going to conduct a rather silly experiment with a Commodore 64. Yeah, you probably read the video description and the title, and I'm going to try to power a Commodore 64 with a USB power bank today. It should generally work just fine if we take some things into account. Let me explain. If you're following my channel here, you probably know that there are two main flavors of the Commodore 64 boards. There's the long boards. There are several revisions of these, which all have a pretty similar power supply section. And there's also the short boards, which are a cost-reduced variant, which has less ICs and more modern ICs, which use different supply voltages. The original Commodore 64 power supply is the same for both variants for all C64s that exist. It delivers 9 volts AC voltage and 5 volts DC. The main difference power supply wise between these two board variants is that the long boards have a 5 volt onboard supply basically and a 12 volt rail that goes through some of the chips, in particular the graphics chip, VIC-2 graphics chip and the SID chip. The older variants of those use both 5 volts and 12 volts. The 9 volts AC are used to derive the 12 volts from. So we are not going to be able to power one of these long boards with a 5 volt DC power supply without modifications. And that's the goal, kind of. We are, however, going to try to power one of the short boards with 5 volts. Yeah, in this case, for this experiment, this has one major advantage over the long board revision, and that is that the graphics chip only needs a dual 5 volt supply. So if we provide 5 volts through our connector here, it should power the graphics chip just fine. So what are the 9 volts AC really needed for? For the short boards, our VIC-2 chip only needs 5 volts. Our SID chip, which is missing on this board, because they are rare and they fail quite often, unfortunately. So there's no SID chip on this one. This one got donated by Bart, actually, as it says. Thank you. So the SID chip that is originally on here, the modern variant of the SID chip, which is the 8580 version, that needs a 5 volts and 9 volts supply. And actually the 9 volts are derived through this rather funky power supply section on this board. They are derived from the 9 volts AC on these short boards as well. But basically that's the only IC that needs the 9 volts AC to work. Another thing that needs the 9 volt AC is the user port. There are some expansions that you can plug in there that need 9 volts. And also the dataset connector won't have power on it. So we won't be able to use the dataset if we power this whole board from 5 volts. But other than that, except for the SID, the user port and the dataset, we will have a working Commodore 64. There's one other thing that the 9 volts AC are used for in these short boards and also in the long boards. The CAA chips 6526, which are general purpose I/O chips, there's 2 of those in every Commodore 64. These have a TOD clock in there as one of their features, and that uses the mains frequency or the 9 volts AC frequency to run, to time the time of day clock. So that won't work. We won't have user port and we won't have dataset. Other than that, we should have a Commodore 64 that's working without the SID chip. But there's a workaround for that, I think. We are going to experiment with that. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype circuit boards of all kinds. They have a PCB design contest going on where you can send in your circuit board designs and have them judged by a jury of professionals. And If you win big. There's some amazing prizes to be won in different categories. So if you feel like participating, I can recommend it. Check out the links in the video description. And now back to our little experiment. Yeah, so as I said, we are probably going to be able to power a short board with 5 volts alone. We won't have sound, we won't have a data set, we won't have a user port. Most things that we connect to the user port will still work because they don't use the AC voltage on the user port. But other than that, this should pretty much just work as a regular C64 minus sound. So let's try and make a cable that we can connect to some USB power source. At the moment, this is connected to my regular power supply that I myself made, one that I still use for testing, which I made ages ago. You can watch the video about that somewhere. I'm going to link it in the corner. I'm going to use this cut up, I think, Apple iPhone charging cable. Usually in these cables, it's not very clearly visible on this one because it's so thin, but there's usually a white and a green wire. Those are the data lines, and you have a red wire and an uninsulated wire or a black insulation. That's the ground is the black one and the red one is the +5, usually. So it's a good idea to measure that, but usually the color codes are the same across these USB cables. Yeah, the power connector for the Commodore 64 power supply is one of these round DIN connectors, and I am going to look up the pinout of these. I don't quite remember where the 5 volts and ground is, so I'm going to look that up to be sure. And after a quick Google search, I landed on Mindflare Retro's Flickr account, and he has a very nice graphic here with the pinout. The front plug side and the back the solder side, and pins 6 and 7 are the 9 volts AC, and 2 and 5 are the 5 volts. So 2 is ground, center pin. It's easy to remember if you are not me. And pin 5 is the 5 volt wire. So we are going to solder that on the DIN connector, I think. Not the prettiest job I've ever done, but it's going to do. And I'm going to add some electrical tape for insulating these wires. And then I'm going to close the plug and measure my voltage with the multimeter to be sure. Yay, there we go. As I said, this is not the best looking thing in the world, and these connectors that I bought are pretty crappy, but yeah. This is just a proof of concept anyway, so yeah, let's do it. Let's prove the concept. So here's a neat trick. If you want to measure a DIN connector, you put some pieces of heat shrink tubing over the pins so you can't short out the other pins with your probes. And obviously we need a power source. I'm just going to use a standard USB power bank here that I usually use to power my camera. Let's see, we should have pretty much spot on 5 volts. Yeah, and we do. 5.1. And the power bank actually turns off if it doesn't detect a load. That's what we've just seen. Can turn it on again. We should have 5 volt. Yeah, there we go. 5.17. That's exactly what I was expecting from these pins. So now here's the interesting bit. I'm just plugging this into my Commodore 64 board here. So in order to determine how much current this draws and if it's safe to connect this to a standard USB port, I'm going to use this charger doctor, which is just a cheap little device that has USB plugs. You can just wire this up on your USB power supply and then wire the thing you are going to power up on this socket here. Yeah, I don't quite know how accurate this thing is. It was rather cheap, but it's at least going to give us some kind of hint into the direction of how much current this thing draws. So let's see. Yeah, I'm pretty curious if this works at all. So we're going to plug this into this, and then this into this. And then hopefully we are going to be able to power a whole C64. So I'm powering this thing on. Should give us 5 volts, yes. Then I'm powering on the C64. And as you can see, 0.7 amps. And the voltage, the voltage dropped to 4.8. So this power bank is not quite up to the part. But we have a working Commodore 64. This is 0.7 amps at around 5 volts. So these chips operate, I think they have like a 10% tolerance on the 5 volts supply. So we're good. This is now not connected to anything but this USB power bank. I think this power bank is rated for 1 amp, so it's working at 0.7 amps, so that's 70% of its capabilities, and it's pretty normal that the voltage drops a bit at this kind of load. But yeah, it does work. I've added a little LED here on my LED connector to the Commodore 64. Pretty handy to have one of these around because at least the Commodore machines have similar connectors for the LEDs. And if you don't have the case handy with the LED built in, you can always use this little plug. So yeah, this is even running a Kung Fu Flash cartridge at the moment. So that is also powered through my little power bank here without any issues. Doesn't even get warm or anything. It's just working fine. Yeah, as I said, in this configuration, we won't have sound, but that's pretty much it. Everything else should work except for the data set and the user port. If you connect something to the user port, like an EEPROM programmer or something like that, there are some peripherals that use the 9 volts AC that are provided on the user port, but not many. So everything else should pretty much work. There are some things, some cartridges on the cartridge port that maybe use the 9 volt, the frequency from the AC. I'm not quite sure about that. But we don't have sound. That's a major issue. I think if you know the Commodore 64 sound, you know how important it is to the system. The SID is just, it doesn't really compare to anything else. However, there are some modern replacements that use only 5 volts as their supply. And we're probably going to be able to have sound from this system if we use one of those. So this is a nano swin SID, a pretty common replacement for the original SID chips. I'm just going to use this because I have it handy. This should run on 5 volts, on the 5 volts rail of the SID chip alone, I think. There's also other variants that should work. Probably the ARM SID should work because that uses 5 volts. And probably the FPGA SID should also work in this configuration. I'm going to try this at this point and see if this works. We could have sound with this. Let's see. Yes, I heard a sound from the nano swin SID. It does totally work. With a SID replacement, you can just use this on a power bank with the cable, like I've shown. And we have a working C64. If you had a monitor with a 5 volt supply voltage, or maybe one of those 12 volts screens that you can use in your car, something like that, it's totally doable to have a mobile real C64. Just powered by a USB power bank. I mean, this is just a proof of concept. I just kind of wanted to figure out if this works at all. And by the way, here's what happens when you want to power a longboard revision Commodore 64 with this. The LED lights up, but that's pretty much it. Doesn't output any picture because the VIC-2 chip needs the 12 volts supply that is derived from the 9 volts AC. And yeah, this is not even going to power on because the VIC-2 is such a main chip for this all to work. So yeah, that doesn't work with the long boards. Here's another thing I want to try. This is a Commodore VIC-20 or a VC-20, which is the German version of the VIC-20. And the later models of these VIC-20s have the same power supply as the Commodore 64 with the 5 volts and the 9 volts AC. And I'm quite curious if this works with a 5 volt supply alone. I don't think so, because I think some of the ICs need 12 volts, but I'm not quite sure. So I'm just going to try. What could go wrong? Oops, okay. Oh, this draws 1.05 amps, but it does work. This goes down to 4.79 volts here and draws a bit more current, 1.04 or 05 amps. But it seems to be totally working, which is rather surprising, but yeah. I guess the cost-reduced versions of the VIC-20 do work with a 5 volt supply alone, and you can just power these with a 5 volt supply. Yeah, that's pretty awesome. Didn't think that this would work, actually. Okay, so the VIC-20 totally works, sound and all. Same thing goes for the user port, which is the same on the VIC-20. We won't have 9 volts AC on the user port here. But as I said, they are not used by many things. I'm now running this from a cartridge, Omega Race. Works fine, sound works, graphics work, everything works. This now draws 1.05 amps at, I think, 4.8 volts, which is perfectly in spec. So we can just power this from a power bank as well. That's pretty nifty. Yeah, I think that's it for today. I think I proved the point that you can run this off a USB power bank. This is not even a very good one, and it still works because it only draws 0.7 amps, 700 milliamps or thereabouts. And obviously we need a switch replacement, but now we are basically good to take this on the road. Which is rather amazing in itself. Thank you very much for watching. Hope you enjoyed this. Thank you if you are a supporter on Patreon or on the channel memberships page. If you are not a supporter, thank you too. Thanks for watching. Thanks for subscribing. Thanks for your thumbs and your comments, and hope to see you again on this channel sometime. I'm Jan Beta. Thanks for watching. See you next time. Bye.